Hello everyone. In the first demo video, we have seen that there are different branches of physics, mechanics being one of the most important branches. So let us look back at what we have seen about this mechanics. Mechanics is further divided into two parts, that is statics and dynamics. As the names suggest, statics is a study of stationary things, dynamics is a study of moving things. Dynamics is further divided into two parts. The first is kinematics and the second is kinetics. Now the names are a little bit confusing, right? Kinematics and kinetics. Before I tell you in detail about these two things, let me first ask you, when you say the word dynamics, that is the study of things that are moving, what does come to your mind when I say dynamics? Let me highlight these things. So when the word dynamics comes to my mind, I start thinking about the motion, and when I start thinking about the motion, dynamics, that is motion, study of motion. So when I think about motion, obvious questions come to my mind, and that is, how is object moving? How long is it moving? How fast is it moving? Right? How long is it moving? How fast is it moving? How is it moving there? These questions come to my mind. Now if I start thinking a little bit deeper, some more questions come to my mind, and that is, okay, that the object is moving, but what is it causing to move? What is it that is causing it to move? So what's the cause of motion? Now these two areas are, the first area is called as kinematics. You study about the motion and the motion alone. How long it has moved, that is called distance. How fast is it moving, it's called speed. How much time is it taking for motion? So time, study of these things is called kinematics. Whereas the study of what's the cause? Do you know what is the cause of the motion? The force, right? So the study of force, the cause of motion, is called as kinetics. So first we are going to concentrate on this part, that is the motion and the motion alone, and without thinking about the cause of the motion. So we'll only talk about distance, displacement, velocity, speed, acceleration, time, etc. things, but won't think about what is the cause of this motion. So coming back to the point, we are going to study kinematics, which is the study of the motion. So the first thing that you should think about is, when an object moves, it moves from one position to another position, right? That is how the motion is described. The object moves, object changes its position, that is called motion. So what is position? If you just think of your Google Maps, or how you specify the location on Earth, we specify it through latitude and longitudes, right? So position is basically, if you put it on a two dimensions, x and y, position A can be specified as x1 comma y1. Basically the coordinates of that point, x1 and y1. This is first position or A position. The particle has to, the object has to start from this position and move to another position B. Let us say that its coordinates are x2 and y2. So motion from A to B, that is position A to position B, that will be described by further things. Now the next thing that comes to your mind is, if it is moving from A to B, that means A to B, or is it A to B, or is it A to B. Out of these three, which path would the object take? And there is no preferable path, as you can see. Any path is okay. Whichever path is available to the object, it will take. So the path that the object takes, the path, and with that path we will get distance as length of the path. So path length is our distance. In this case, our path length is this plus this. In this case, it's straight. And in this case, it's curved path. So the length of these paths is called distance. Whereas the net change in the position of the particle, that is from position A to position B. What is the net change? By whichever path it takes, what is the net change from A to B? That is this distance, a straight line distance joining the 2 points. How can I find this distance? Basic formula in math. Square root of x2 minus x1 the whole square plus y2 minus y1 the whole square, right? That is this straight line distance. That is called displacement. So to get the things straight one more time, displacement is straight line distance between any 2 points, whereas distance is the length of the path that you take, and it could be any path. Now, as it might be obvious to you, even this is one of the paths. So if I take a straight line path between the 2 points, what do I get? Distance and displacement, they are equal. Now we will see different cases of distance and displacement. I will show you different paths and see if you can judge what is the distance and the displacement. So let us say that particle moves from point A to point B over circumference of a circle. What is the distance? It's the length of the path. So it's pi r, because the entire circumference of the circle is 2 pi r. Half of it is pi r. So that is my distance. Whereas the displacement must be straight line joining the 2 points. That is 2r. That is the diameter of the circle. That is my displacement. Now can you tell me a case where distance is there, it's some numerical value, but the displacement is not there, it's 0. Can you tell me one such case? I'll draw it. It's the extension of this circle, the full circle. If the particle starts from A and then moving around the circle, it ends up again at A, then your distance traveled is 2 pi r, whereas displacement is 0, because there is no net change in the position of the object. Change in the position is displacement. Length of the path traveled is distance. So there is no change in position, displacement is 0. I'll give you another example of 0 displacement. So the particle starts from this point, goes to some other point B, and then comes back to A. So this is the entire motion. How much distance has it moved? It has moved A to B plus B to A, that is 2 times AB. That is my distance. But what is displacement? It is 0. Why? Because it has come back to its own position. But that's not the only difference between distance and displacement. Of course, the difference is major, but that's not the only difference. There is something called as scalar and vector. So scalar is the quantity that only has a number. Like we say, the distance is 2 meter, distance is 5 meter. That's just a number. But we don't specify whether it traveled from A to B or B to A. Because if you measure the distance from A to B, it's going to be some length L. If you measure it from B to A, it's again going to be the same length L. But if we talk about the displacement, you have to specify it as a vector. So basically, you have to specify the direction along with the number. So you have to say the displacement is L from A to B. or the displacement is L from B to A. You have to specify the direction along with the magnitude. We'll see in detail about all these things when actual lectures start. Thank you. So as we have seen, kinematics is a part of mechanics, a sub-part of mechanics. This kinematics can be discussed in different dimensions. Basically what I mean is kinematics could be 3D, 2D or 1D. I'll explain with examples what exactly I mean by different dimensions. When you walk, if you walk just forward and then backward, it's called one-dimensional motion. One dimension. So only in x direction I'll walk forward, in minus x direction I'll walk backward. That is a one-dimensional motion. If I start walking around the room, all over the room, if I start walking in x and y directions, that is a two-dimensional motion. Whereas if I get out of my home, if I go to the ground floor, then go to the road, that's a three-dimensional motion, because one more additional dimension is involved, that is the depth dimension. I went down 2 floors and then went to the road. So it's x, y and z direction of the motion. So in 1D kinematics, we will not consider these two parts of the motion, and we will consider that the only motion that is involved is in one dimension, that is either the forward motion or the backward motion. Okay. Now, since we have already discussed these three terms, position, distance and displacement, I will give you an example now. Let us consider, there are several examples of one-dimensional motion as such. For example, if you start walking towards your school from your home, let us assume that your school and your home has a straight road joining them. So you are just walking in one dimension. Okay, now when you walk to your school, you don't walk straight, right? You first visit your friend's building, you call him up, then he joins you, you walk towards the school, probably you'll end up somewhere in another shop, buy something, buy a chocolate, and then you go to the school. So this is a one-dimensional motion, but it didn't happen with the same speed, right? You stop in midway somewhere at some places. That is a classic example of one-dimensional motion. Another example that I can give you is the motion of a train. Let us say it's a Duronto or Rajdhani train that starts from Mumbai and goes to New Delhi. The distance, approximate distance between Mumbai and New Delhi is 1500 kilometers. The distance is huge, right? It's approximately equal, if you just Google it, you'll get this distance. It's approximately equal to 1500 kilometers. Whereas a fast train like Duronto or Rajdhani, it takes around 15 hours. Approximately it takes around 15 hours to cover this distance. So can you do a quick calculation and tell me what is the average speed of this train? It is 1500 kilometers divided by 15 hours. So that makes it 100 kilometers an hour. Mean that the speed of the train is 100 km per hour in the entire journey from Mumbai to Delhi? No, right? Because you know that from Mumbai to Delhi it takes several stops. Let us say even if it is a fast train, it takes 4 or 5 stops between Mumbai to Delhi. So a few stops are longer ones for 10 minutes or so, and a few stops are brief ones, say 2 minutes or so, but it takes those stops. So when the train has stopped, how much is the speed? It's 0. When the train is running at full of its speed, probably the speed is 120 km per hour. So sometimes it is 120 km per hour, sometimes it is only 60 km per hour, sometimes it is 0 km per hour. But when we say it is 100 km per hour, we are talking about the average speed of the train. So that's your next concept, average speed. And how can we express this average speed? The formal definition for average speed goes like this: average speed is equal to total distance by total time. Like we could intuitively find out in the previous example that the total distance between Mumbai and New Delhi is 1500 km divided by total time is 15 hours. So average speed is 100 km per hour. But remember that it's average speed. Now, if you discuss or if you want to see the speed of the train at any one instant of time. It is called as instantaneous speed. For example, if you want a train's speed when it is approaching the Surat junction, how much is its speed? Let us say it is 60 km per hour at that point of time when it is approaching the Surat junction. Then that is called as instantaneous speed. Speed at an instant. Okay, so that is called instantaneous speed. Like we said, the speed could be sometimes 0, could be sometimes 120, could be sometimes 60, 70, 80. These are all instantaneous speeds. So speed at any instant of time is called as instantaneous. So the velocity, average velocity and instantaneous velocity. For understanding these concepts, you first need to understand what is the difference between speed and velocity. So as I had discussed in the demo video, speed is a scalar quantity, velocity is a vector quantity. What does it mean? Speed, we specify speed as 100 km per hour, but that does not talk about the direction of it. That means if the train is going from Mumbai to Delhi, or is it coming back from Delhi to Mumbai? Either cases, I will say that the speed of the train is 100 km per hour. But I will not specify the direction because speed is anyway 100 km per hour. But if I assume that the direction from Mumbai towards Delhi is positive, then automatically the direction from Delhi to Mumbai becomes negative. So while going towards Delhi, if the speed is 100 km per hour, I have to specify it as minus 100 km per hour when coming back from Delhi to Mumbai. And that is where the velocity comes in picture. So speed could not tell you about the sign of the motion, basically about the direction of the motion. That is where your velocity comes in picture. Velocity tells you the direction. So average velocity, it will be either plus 100 km per hour or minus 100 km per hour depending on how the train is moving. The formula for average velocity, it goes like this: total, yes, you guessed it right, total displacement by total time. So it automatically takes care of the sign because the displacement is positive. As you have defined the direction from Mumbai to Delhi as positive, the displacement towards Delhi is positive. Try to recall how I have defined the displacement. Displacement is the change in the position. What is the position of Mumbai? Let us say it is 0. What is the position of Delhi? Let us say it is 1500. That means 1500 km, right? Now what is the total displacement? If I say from Mumbai to Delhi, it is change in the position. So it is 1500 minus 0. Change is always expressed as final minus initial. Remember this sentence for the entire physics course. Whenever I utter a word change, it is always final minus initial. How do we define change? Change is always final quantity minus initial quantity. So if I say total displacement is the total change in the position, it is final quantity minus initial quantity. It will be 1500 divided by total time taken 15 hours. That will give me 100 km per hour as the velocity while moving from Mumbai to Delhi. While coming back from Delhi to Mumbai, what is the total displacement? What is initial position? Initial position is Delhi. What is final position? It is Mumbai. So what is the velocity while coming back? It is final position minus initial position. So it is 0 minus 1500 by same total time it will take while coming back from Delhi to Mumbai. So that makes it minus 100 km per hour. This minus sign takes care of the direction. That is where the velocity has its own importance. The instantaneous velocity goes on the similar lines. This talks about the average velocity, but while coming back the speed could be sometimes 60, sometimes 70, sometimes 80, sometimes 120, 150. Same way instantaneous velocity could be, now since I am coming back I have to say instantaneous velocity is minus 60 or minus 70 or minus 120 or minus 80 or minus 20 or 0, right? So that is what is our instantaneous velocity. Now if you have understood all these concepts well, I'm going to give you a very small numerical for having a better understanding of this average speed and average velocity. These two terms, for them I'm going to give you a small example. So take it down. So let me explain you how these all terms are calculated by giving a very simple example. Here at point A, a person is standing. He will travel to point B, which is 50 meters ahead of him, and then will return back immediately to point A. While going, his speed is 2 meters per second. While coming back, it's fast, so it is 5 meters per second. And the distance between A and B is 50 meters. So we'll try to calculate all these points: position, distance, displacement, average speed, average velocity, instantaneous speed, instantaneous velocity. These two things are already given in here. So as I have already explained, instantaneous speed is the speed at an instant. So if you take any instant in between A and B, the speed everywhere is 2 meters per second, which is already given. If you take any instant in between B and A, the speed is 5 meters per second, velocity will be minus 5 meters per second. So instantaneous quantities are already given. In this particular case, it is called a uniform speed or uniform velocity case, where instantaneous speed for any section is equal to average speed for that section. Instantaneous velocity for any section is equal to average velocity for that section, because it's constant everywhere. So even if you take the average over the entire span, it's going to be the same value. So it's everywhere 2, 2, 2, 2, 2, 2, 2. You take an average of 2, 2, 2, 2, you will again get 2. If it's 5 everywhere, you take an average of all those instances, you will again get 5. And that is why instantaneous and average quantities over those sections are same. And those instantaneous quantities are already given. So let us first take up the position. So position at A, that I will assign. So I will assign it as 0. Since it is a one-dimensional motion, only one dimension or one coordinate to position is sufficient. If had it been a two-dimensional motion, we would have to give it as x comma y. So 0 comma 0 is what I would need to specify if it is two-dimensional motion. But this being a 1D motion, only 0 is sufficient. For B, obviously it will be 50 meter, because it is at a distance of 50 meter. So for B, the position is 50 meter, and for A, position is 0 meters. So this being a very simple numerical, these are the only two position coordinates we have. The distance between point A to B. So distance, as it is defined, it is the length of the path. So while you are going in this direction, what is the path length? It is 50 meter. So if I ask you what is the distance AB, you will say it is 50 meter. If I ask you what is the distance BA, will it be minus 50 meter? No, it will be again 50 meter, because distance doesn't take into account the direction. So even if you go from B to A, the distance between 2 points, it will stay 50 meter. What is the distance of ABA? That means A to B and back to A. What is the distance? You traveled how much distance in total? It is 50 meter plus 50 meter. So it is 100 meter. So we covered position, we covered distance. Now let us talk about the displacement, and that is where the interesting point comes in. So displacement of AB, it is denoted by S. Usually the distance is denoted by D and the displacement is denoted by S. So displacement of AB is equal to, since it's a straight line distance, it will be equal to 50 meter. Displacement of BA. Now remember, displacement, it is a vector quantity, so it takes into account the direction. So BA displacement and AB displacement, though magnitude wise equal, but they will not be equal. This is minus 50 meter. Only the magnitude is same. Now if I ask you what is displacement of ABA, that means A to B and back to A, try to recall. I mean, it is obvious from this that it has to be addition of the two, so it is plus 50 minus 50 is going to be 0. But try to recall the basic definition of the displacement. Displacement was defined as the change in the position. So what is the position when you started? It is 0. What is the position when you ended? It is 0. What is the change in the position? It is 0 minus 0, so that is 0. And that is why displacement of path ABA is 0. Whereas the distance for that path is 100 meter. That is where the displacement and distance they differ. Now going to the next point. So we covered our position, distance and displacement. Going to the next point, average speed. So if I ask you what is the average speed of AB section, so speed average of section AB, how much will it be? As I said, average and instantaneous are equal because the speed is constant everywhere. It is 2 meters per second. Speed average of section BA, that means while going from B to A, it is not going to be -5, it will be +5 because again speed is not a vector, it's a scalar, it does not take into account the direction. You will just specify that how fast are you moving? You are moving with 5 meters per second. Does not matter which direction you are moving. But the velocity of, so average velocity of section AB will be +2 meters per second. I am by purpose denoting this plus sign because velocity average of section BC is going to be -5 meters per second because velocity should denote the direction in which you are moving. Now the average velocity of section ABA, average speed of the section ABA, how much will it be? Speed average of ABA, how much is it? It is 2 meters per second for this section and 5 meters per second for this section. How is average speed calculated? Try to recall the definition of the average speed. Average speed is defined as total distance covered by total time, right? That was our definition of the average speed. So how will average speed be given? Speed average of section ABA, how much will it be? It won't be 5 plus 2 by 2. It won't be 5 plus 2, that is 7 divided by 2. You have to go by the actual formula given. So what is the actual formula? Total distance by total time. So do you know total distance? Yes, it is 50 plus 50, that is 100 meter divided by total time. Do you know the total time? No, not yet, but you can calculate it. Now what is the total time taken for A to B? We know that speed is equal to distance by time. So time is equal to distance divided by speed, right? So we get time for section AB. Time AB is equal to 50 by 2, which is 25 seconds. Distance divided by speed, it is 25 seconds. Time for section BA will be equal to again distance divided by speed, which is 10 seconds. So for section AB it is 25 seconds plus for section BA it is 10 seconds. So how much will it be? 50 plus 50, 100 divided by 25 plus 10, that is 35. 100 divided by 35 meters per second is your average speed for ABA motion. And if you just calculate it, you will find that it is not equal to 5 plus 2, that is 7 divided by 2. That means it is not equal to 2.5, it is something or rather 3.5. 7 by 2 is 3.5, but it will not be equal to 3.5, it will be something else. Okay, do that exercise and let me know. Now coming back to velocity. Oh, so this is not BC, this is BA, right? There is no C, it is AB and BA. So velocity average for AB section is 2 meters per second. Velocity average for section BA is -5 meters per second. Now what is the velocity average for section ABA? Now what is the definition of the velocity? Some of you might have already guessed what it is going to be, but let me go back to the definition of the velocity. Velocity, what was our definition of the speed? It is total distance by time. What is the definition of the velocity, average velocity? It is total displacement by time. Now can you tell me what is the total displacement of section ABA? ABA, we already discussed it, right? ABA, there is no displacement because there is no net change in the position. So this is simply going to be total displacement 0 by total time, which we have already calculated, which is 35 seconds, but that doesn't matter how much the time is, it is still going to be 0 meters per second. So average velocity for this section is 0 meters per second. And see, average velocity is 0, but average speed is 100 by 35 meters per second. So that is where, like our distance and displacement were different, our speed and velocity are also, average speed and average velocity are also different. So now we have covered average speed, average velocity. Instantaneous quantities are already given. Now in the next lecture, I will give you a tougher numerical and you will have to solve it. I will also solve it, but not by this method. I will give you another method for solving that numerical. Thank you.